You promised a just right distance, and all I see is the same old everywhere.
Because just right is not a place you park at. It is a distance you measure.
You said just right is a real place, a distance where water could stay liquid instead of steam or ice.
It is real, and today we chart it properly, what it can promise and what it cannot.
Then tell me where it is, so I can be the first to stand in it.
That is the lovely trick. You have stood inside one your entire life.
I have what?
Hold that thought while I draw the map.
Vega and Qubit, and the just right distance.
Every hunt needs a quarry, and ours is the plainest treasure, liquid water.
Water? The stuff I splash in the sink?
The very same, and every living thing we know needs it liquid.
Why liquid? Why not ice or steam?
Because liquid water is where chemistry gets to mingle. In ice, the pieces stand frozen like a photograph, and nothing new gets made. In steam, they scatter so far apart they almost never meet.
But liquid is the dance floor.
A dance floor for chemistry. Keep that picture close.
So we are not hunting planets, we are hunting puddles.
Oceans, if we are lucky, but yes, we are asking where puddles are possible.
Possible. That word is doing a lot of work, isn't it?
All of the work, and I promise we will come back for it. Now picture a campfire on a cold night.
Sit too close and you roast, sit too far and you shiver.
And in between lies a ring of ground where you are simply comfortable.
Every campfire has one, whether anyone sits there or not.
Swap the campfire for a star, and that ring becomes the just right distance. Close in, a world's oceans boil off into steam that never rains back.
Too hot.
Far out, every drop locks solid and stays that way for ages.
Too cold.
Between those two fates lies a ring of distances where water can stay water.
Not too hot and not too cold.
Scientists call it the habitable zone. Your words are the honest translation. Not too hot, not too cold. The ring where liquid water gets its chance.
Draw the edges sharper. Where exactly does too hot begin?
Ah, you have found the honest secret of the map. Nobody can, because where water survives depends on more than distance alone. Clouds can shade a world, and air can blanket one, and each moves where boiling begins. So different scientists, guessing carefully, draw the band a little wider or narrower. The just right distance is a band, not a line, soft at both edges, honest about its own blur.
A map that admits where it is fuzzy. Somehow I trust it more.
Now for the part that multiplies the map by 100 billion.
Go on then, multiply.
Every star casts its own warmth, so every star wears its own band. A small, cool star glows gently, so its band hugs close like a ring around a candle.
A world in that band would practically sit in the flame's lap.
So close that its whole year passes in a handful of days.
A year shorter than a school holiday.
While a big blazing star pushes its band way out into the cold quiet.
Same rule, different fire.
One rule for every fire in the sky, and you remember how many fires that is.
More planets than stars, you said.
And around every one of them, near or far, a band is quietly waiting. Even the nearest star to our sun keeps a small world inside its band.
The nearest star has one?
Its year lasts 11 days, and whether it kept any air, nobody yet knows.
Then bands are everywhere. So why has every band not filled with oceans?
Because the band writes an invitation, and an invitation is no guarantee. And to see that clearly, we only need to look next door.
Next door as in our next door?
Meet Venus, Earth's twin in size, wearing the thickest air of any rocky world we know.
A twin, so it should be Earth's story all over again.
Venus stands just sunward of the band's inner edge. Some drawings almost brush it.
A near miss then. Surely a near miss stays nearly nice.
Its heavy air traps the sun's warmth like a blanket over a blanket over a blanket. The warmth piled up until the oceans it may once have had were gone. Today its surface is the hottest of any planet around our sun, hot enough to melt lead.
Hotter than Mercury, which sits closer to the fire?
Hotter than Mercury, distance dealt the cards, but the air played the hand.
So a world can stand nearly right and still lose everything.
The distance invites, the atmosphere decides.
That feels like a warning written in the sky next to us.
There is a second warning, and it hangs even closer to your window.
The moon?
The moon rides beside Earth, squarely in the sun's band, dead center of just right.
The moon is in the habitable zone.
By distance perfectly, yet not one puddle, not one cloud, not one breath. With no air to hold warmth, its daytime ground roasts past 100 degrees. And at night, the very same ground plunges to more than 100 below.
Boiled and frozen every day at the same distance where Earth stays gentle.
Same distance, no air. The band never promised the moon a thing, for bands make no promises.
So being in the band only ever meant water was possible.
There is your word again, and it does all the work.
All right, Venus lost its chance. The moon never had one, but Earth got lucky.
Now brace yourself, because Earth's luck is stranger than you think. Strip away Earth's air, same sun, same distance, and guess what the oceans do?
Nothing happens. We are mid-band. You drew it yourself.
A bare Earth at this very distance would freeze over, pole to pole.
Freeze. Inside the just right distance?
Its average would settle near 18 below zero, every sea standing solid. Our blue home would be a frozen white marble without its blanket of air.
Then what is keeping my toes warm right now?
The thin coat of air you never notice holding in warmth 33 gentle degrees. The blanket trick that ruined Venus, worn thin, is the very thing that saves us.
So the villain of the last story is the hero of ours.
Not villain, not hero, a tool, and everything depends on the dose.
The just right distance was never quite enough then, not even for us.
One more secret, my favorite, the band itself does not stand still.
You told me once, everything in the sky has a biography, even the light that wakes you.
And as our sun's biography turns its pages, it burns very slowly brighter. When the sun was young, it shone about a third fainter, so the band sat closer in. So young Venus may once have stood inside it, and may even have worn oceans. Nobody is certain.
So maybe Venus did not break the rules. Maybe the band drifted out from under it.
That is one honest telling, and Venus's full story is still being read.
Will the band keep drifting away from us too?
So slowly that our middle-aged sun will keep Earth in the band for ages and ages yet.
Good. I was about to write the band a strongly worded letter.
Now you can read the map the way scientists do, carefully. Find a world in its star's band, and we know exactly one thing. Liquid water is possible there.
Possible, not present.
Could, not does. The band tells us where to look, never what we will find. It cannot see the air, cannot smell the water, cannot promise anybody home.
And of the more than 6,300 worlds we counted, some sit in their bands?
Some do, small worlds at just right distances around stars near and far. How many sit inside depends on where you draw the soft edges, so even the count is a question.
Every one of them a maybe.
And one of them, long ago, was a maybe that came true.
Us.
Right distance, right blanket of air, and time enough for the dance floor to fill.
We are not just inside the band. We are proof the invitation can be answered.
Which leaves the question Season 2 was built to chase.
All those maybes out there, how do we ask them if anybody answered?
The distance invites and the air decides. Next adventure, we learn to read a far world's air from the ship.
If just right turned out to be half the story, subscribe so you are here when we read a world's air.
Setting course for the air of other worlds.
See you out there, explorers.